Hello everyone, my name is Adam Farley and I'm here representing the Adopt OpenJDK community, and today I'm going to be telling you about lessons learned for the new build farm for Java itself. It's okay if you don't understand every word in that sentence. We're going to be covering it all one step at a time so that nobody gets confused. So here's what we're going to cover. Today we're going to cover the basics. What is Java, what is OpenJDK, that sort of thing. We're going to be talking about Adopt OpenJDK, how that fits into the picture, the history. We're going to be going through a demonstration of our build farm. We're going to be talking about the principles of continuous integration, so the theory behind what we're trying to do, how we're trying to do it, the philosophy, if you like, and the build farm tech. So the different pieces of technology that we've brought together to create our build farm. Okay, picture at the top is me, that's Adam Farley. I'm an Adopt OpenJDK contributor, I work at IBM. The fellow at the bottom is Daniel Bryant. He can't be here today because he's flying over to America a little early. We're going to be giving this exact same talk at Oracle Code One in San Francisco next week at some ungodly time in the morning. So, you know, you got the better deal here. And here's some key links. We considered printing these off on little bits of paper, but I thought to myself, this is just going to make things harder for the cleanup staff at the end of the day. Everyone's got mobiles. If you want to follow up and ask questions, we've got Slack channels that are active every day. So just drop by the website, ask questions. You can take a picture if you want to keep the links. Oh, and we'll have this up at the end as well. So there you go. Background. What is Java? Java is a programming language. Hands up, who here has heard of Java? Excellent, I can skip this part of the presentation. Java, the programming language, gets compiled and turned into things called Java bytecodes. Now, what that is, you don't need to worry about. But what these bytecodes do is they run on top of something that's also called Java, and that's the Java executable. And that can sit on top of lots of different operating systems, lots of different platforms. And it's Java that we're going to be talking about here today. That's what we're building. The Java development kit consists of the Java runtime environment, that's the core Java ebit, and tools to compile and debug Java code for Java applications. That's outside the scope of this talk, but there's a lot of them. The JRE consists of libraries. You've got class libraries, so classes like string, classes like integer, classes like file exceptions. You know, any number of library classes. You've got the Java virtual machine that Java runs on top of. It's the interface layer, if you like, between the bytecodes and the operating system. It's the engine at the heart of Java. It turns the bytecodes into actions, basically, on your computer. And you've also got the Java plugin applets and Java Web Start. What is OpenJDK? OpenJDK is the reference implementation for Java 7 onwards. So when someone says, this is Java, then they're defining that by comparing it to OpenJDK. So OpenJDK is the gold standard for Java, basically. You get variations, you have interpretations, you have derivative implementations and things like that, but it all comes back to OpenJDK because they're the ones who set the pace. It's free, it's open source, anyone can take a look at the code. It's under the GNU General Public License with class path exception. Anyone who's worked with licensing knows that the GPL can be contagious. You get it near your code, it spreads. But the class path exception is good news because it means that you can put your code next to a piece of GPL code and it's okay, it won't spread across. What is the OpenJDK? It's a source to build your own Java. So if you just download the OpenJDK source from the OpenJDK project, the OpenJDK community, then you can build your own on your desktop. And you get Twitter, who've augmented the JDK. You've got Amazon, who've worked in the community. You've got IBM, who's worked heavily in the community. You get a lot of companies donating little bits of code, anything from typos to full-blown features. And it's up to the individual to decide how heavily they want to get involved. But there are a lot of people out there. And it is a great opportunity to learn more about the internals of Java. You'll learn that there's a lot inside of Java. So you'll learn a lot, but it depends on what tasks you get involved in as to the breadth of knowledge that you're actually going to gain. From Java 11 forwards, the Java you get from Oracle and the Java you get from OpenJDK are going to be essentially identical. There are some cosmetic and packaging differences. There's some details here. Mostly they're obvious when you start to run your code. If you go in expecting minor differences, then you can usually plow through the worst of them pretty quickly. And there's comprehensive details if anyone's interested, which I'm not. We've got various different implementations of OpenJDK. You've got things like ICE-T, which is Java built using only open source projects. The original Java open source implementation had a bootstrapping problem. You needed another Java in order to build it. In fact, that's still the case. And since back then, the only Javas around were the licensed versions that you got from Sun. They had to find a way to build Java without using Java. And that was a big old headache, but they found a way, they made it happen. And Fedora was very, very happy. And so that's another implementation of OpenJDK. You've got Zulu, which is Azul's taking the OpenJDK source and building it. So you've got lots of different flavors of OpenJDK. As far as I can tell, Zulu is just a straight build though. But you can call it Java, which is good. And you've got Eclipse OpenJ9, which was IBM's JDK until they put it out into the open, and now it's just another flavor of OpenJDK. Java is still free. I was instructed to put this picture up here because it's very important, but I was advised not to try reading it because there's a lot of text on that slide and it's not very useful. But it is still free. It is still free for people to just go and download if you want to. This evening you wanted to go and grab a copy of the OpenJDK source and build your own Java. It is now easier and faster than it has ever been before. It really is. And what does OpenJDK consist of? It used to be that OpenJDK was split into lots of different repositories that you had to pull together. It was divided up into lots of different sections, and thankfully you don't need to do that anymore because they've unified them into one repository. But you know, a pie chart with just one color isn't much of a pie chart, so we use the older pictures because they're more colorful. History. There's a nice little slide about OpenJDK history. It's of interest to historians, but not to me. The history section of today's slides is going to be mainly about Adopt OpenJDK. So what is it? Where did it come from? Adopt OpenJDK started with a pair of projects that kind of came together to form Adopt. And the first of those projects was called BetterRev. Now, BetterRev started in 2014. Anyone who's worked with the OpenJDK community knows that whenever you're submitting a change or a patch or a fix or an update or whatever for consideration by the community for inclusion into OpenJDK, you have to pass it through a tool called WebRev. It basically creates a set of diffs that clearly outline the new code you're adding or the code you're taking away, and ties it together with some nice little bits of HTML so you can dig through those changes nice and conveniently. And then you package that up, send it off to the community, and that's good. but it is very manual. It doesn't really give you any assurances in terms of quality. You can end up sending it to the wrong mailing list. It's not a very good design, which is why a group of people in the LJC originally came together and thought, we can do this better. So they came up with BetterRev. Some of the difficulties they were trying to fix was getting started can be quite daunting. You have to tick a lot of boxes. You have to try and figure out the OpenJDK mailing lists in order to contribute code. If you've just got something you want, if you've just got a problem you want to solve, it can be annoyingly difficult just getting in there and showing your code to the community. Because they want you to sign things and they want you to find the right categories, and oh no, you need to talk to this guy, and oh, you need buy-in from these people. Thorough testing is quite challenging because their testing infrastructure is only available to people who are already committers. So unless you're familiar with their testing infrastructure, with running their testing yourself on your desktop manually, then you kind of just have to either write your own tests or throw your code at them and hope. And even then, when they run their tests, they just have a binary yes or no that comes out of their testing material, and it's not really helpful for them either. So we thought, okay, there's more difficulties. Discussions and incorrect mailing lists we've already discussed. It's a lot of work for the reviewers. Quality is a problem. Yep, and here's with the BetterRev. You had mirrored OpenJD repositories in Bitbucket. I think this was before GitHub was a thing. You had a community-driven web portal. You had a single-click setup, so new people could just go in, show up with a bit of code, and it was designed to be very easy, very user-friendly. You've got automated quality review of patches. You had testing automation built in there. So you just push a bit of code in and it would run some tests and come back to you. And so you'd know what kind of quality your code was going forwards. And you had move discussions to code. Move discussions to code, that's an awkward way of saying that the code was connected to the mailing lists associated with the section of code that you were trying to change. So instead of you trying to find the right mailing list first and then delivering your changes, you deliver your changes first, and then the automation would find the right mailing list and update the right people for you on your behalf. So you didn't need to mess around with any of that. Here's a nice diagram of what it was going to look like, but that's mostly academic because it fell over. The community as a whole, if you're showing up there, especially if you're new, and I know this firsthand, does not like people who show up out of the blue and propose large changes. And even if you've been in the community a while, you have to know the right people. You have to gather buy-in first. You can't just show up with this great idea. Sometimes it'll work, most of the time it won't. You need to sell them on the concept before you try pushing code on them, because they're not going to sit down and take the time to read it. So it didn't work. It was far too big. It was too ambitious. It was, before its time. So just as it was falling down, enter IBM. IBM had gotten it into its head to get more involved in open source communities. They were ready to start throwing their weight around, putting some manpower out there. And they'd just gone out with OpenLiberty. They'd gone out with Eclipse OpenJ9. That's IBM's virtual machine for Java. So it would replace the default one in OpenJDK. It has various upsides and downsides compared to the open one, but we're not going to go into that. It's an alternative implementation of the engine at the heart of Java. Okay, the Eclipse OpenJ9, so that's IBM's VM gone into the open. They were looking to distribute their Java, and you had the BetterRev community who already had this prototype infrastructure for building and testing Java. So they kind of found each other and lived happily ever after. You had IBM looking to throw manpower and resources at Build Farm for building Java in the open, for testing it. And you had the BetaRev guys who had that, looking for someone to fund their development for their own little build farm. So they came together, and what they forged was Adopt OpenJDK. And what Adopt OpenJDK is basically a big, massive build farm. What they do on a daily basis is they grab new code from OpenJDK, they take it internally, they build it on lots of different platforms. We'll be going through that in a bit. Then they test it. We have functional tests, we have system tests, we have thousands upon thousands. We have the test that OpenJDK runs itself. We're going to be going through that in a bit more detail later. And if it passed enough of our quality assurance stages, then it gets released to our website, and the general public can get at it for free, which is good. It really is very good, actually. It's a very active community. And yes, so Perfect Storm, Substantial Code and Engineering Assistance, myself among them.
Excuse me, is LJC the London Java community?
I believe so, yes. It has been referred to as the London Java community a number of times. In a recent email, it was referred to as the London Jamiroquai community or something like that. So I and a number of other people have been very confused. But I still think it's called the London Java community, yes. I need to confirm that. IBM did donate its testing infrastructure. There's a testing framework that we're very proud of. It's called STF. I can get into it later if anyone isn't bored enough yet. And we gave that out into the open. We pushed a lot of our testing infrastructure out. We gave them a lot of our test talent. In a space of weeks, OpenJDK was able to churn out some high quality binaries that were very good. Very good in that they passed all the tests that we hoped they'd passed, which was very good. Adopt OpenJDK did grow to 60 plus repos. Thankfully, I think we have fewer repos now. And we had 600 plus volunteers in 6 to 9 months. I'm assured the numbers on that are accurate. However, how many of those people are active on a day-to-day basis? You know what it's like. You get some people who are active at midnight on a Sunday eve, and you get some people who maybe log in once or twice a month. But it's definitely a very active community every single day. And a technical steering committee is being formed to ensure quality and security at the peak of our little duocracy. And anybody who does not know what a duocracy is it's a bit of a dictatorship where the people who do the work get to dictate what gets done, how the work gets done, and when it gets done, and where it gets done. So the technical steering committee is going to be made up of all of our shoutiest people. The build farm, the resultant build farm, was very well structured. We paid a lot of attention to what we wanted it to look like in the end first before we started laying hands on code, and as a result, it's very well put together, if I do say so myself. It does churn out binaries every night, which are distributed on the Adopt OpenJDK website, which I can show you afterwards if you like. And here is the demonstration. Here is the build demo. I've got a note here that says, use the website to launch the pipeline. Unfortunately, I don't have access to launch the pipeline yet. So we're going to be doing this through slides. I hope nobody minds. Here is the structure. We're going to be going through this again afterwards, so don't worry if not all of it makes sense. First, we've got the pipeline job. In this case, it's OpenJDK 10. So this gets kicked off, and then what we do is we generate jobs for each of the platforms that we want to build on. So if we're building for JDK 10, here's a breakdown of the different sub-jobs that are created to build JDK 10 on Mac using the default VM. As you can see, we've got the build job here, which executes the build, and then once it's built, it executes the tests and the regression tests and the system tests at the same time, and then we sign off on the build and we push it out into the open, and as we can see here, publish to GitHub, and it's right at the end. And GitHub is just where we store the builds after we've built them, assuming they pass all of our rigorous testing. Or unless something's gone hideously wrong and the testing just says it's passed, but that never happens. Okay, here is Jenkins. Who here has seen Jenkins before? Okay, so some have, some haven't. Jenkins is it's a job management system is what it is. You cluster together tasks that we call jobs, and you give it a list of machines that it can run those tasks on. And what you basically do is you open up a job, you click on one, and you say, go do this on the next available machine that meets your needs. And it goes off, it grabs one of its machines, and it runs through the tasks. And we have pipelines here, which are basically several tasks linked together. It's a smart way of managing lots of different machines on lots of different platforms and running code or running whatever on each of them. So first we're going to select a folder at the top, which is build scripts. And in here we're going to select the Java 11 pipeline. And as you can see here, you've got the history of past builds, and you've got the one that was running when we took this screenshot. And each of these is the different platforms that we support, along with the VM variations that we support on them. So this, for instance, is Linux on OpenJ9. That took 25 minutes. And this is Linux on Hotspot, which took 32 minutes. And as you can see, it's all very green because everything's passing and everyone's happy. Whenever you want to launch a new build, you can click on Build with Parameters. These also run, you can also set these things up to run automatically, by the way, which they do every night. And if you click on one of those, it brings up this sort of window. It's where you can set the parameters for the build. Here we've got the list of the different platforms that we want to build on. And for each platform, you can specify the different type of VM you want to build in. And down here we have other parameters. Do you want to run tests on this? Do you want to give it a specific tag? Do you want to use a particular branch, a particular source for your build? And additional arguments down the bottom. And then you just click go. And then when you click go, it launches a selection of these jobs. Here we go, we'll pick one as an example. That's Linux 64-bit being built on Hotspot. And as you can see, this is in progress. You've got the top one on this little table. And as on the previous slide where I showed you the Mac breakdown for JDK 10, first we do the build, then we run the regression tests and the system tests and a few more tests. And as we scroll along, you get the other steps in the build process, and it basically goes from step to step. A few of them can be run in parallel, some of them can be run sequentially, some of them have to be run sequentially. But ultimately, it just goes point to point to point, and if it passes all the steps, then you've got a good build at the end. And that's a load of code in the output. It's just to give you an idea of what a screen full of text looks like. I don't know. At the moment, it's installing FreeType. I think it's a font rendering piece. But yeah, so it builds and it fills the screen with text, and it's all very impressive. It's a great way to look like you're working. If you just put it on the screen, it's just scrolling continuously. And here we go. Like I said, you've got some points which can be run sequentially, which have to be run sequentially. So you've got one step at a time, and some bits, like all of this, which can be run in parallel. So you've got all these different builds being run on all these different platforms with all these different VM variants, and you can run these all at the same time because we have a lot of different types of machines, and Jenkins is smart enough to pick the right machine for the job each time. Now we're going to select one of those. That's the Mac 64-bit build. And yes, we do have Mac builds for Java. And here we go. We have the breakdown again. We have the build, which is happening first. Then you have the different tests, which can be run in parallel. You've got regression, you've got performance, you've got system test. And then after the testing is complete, you sign off on the build, assuming it's all passed, and then you reach the end. It's a nice little graphical way to break down what's going on.
How different are each of the platforms? Are they really the same sort of jobs being done on each platform?
That's a difficult question. We try and keep the interfaces the same per platform, but the deeper you get inside things, the more different it gets on different platforms. So things are going to look a lot different for Windows than they're going to look for Linux or Mac. Some things are going to require special characters. Sometimes you compile with GCC, sometimes you compile with XLC, and different options used at different stages. By and large, we try and keep the number of special cases to a minimum because we don't like having to split our code up. But we keep it separate so it's clear what's going on. And this is the result. When all the builds are complete, you've got a list of all these different builds, all these different artifacts that have been generated. As you can see, each one's been paired up with a nice little SHA number. Those are useful if you want to download builds programmatically and then verify that what you've got hasn't been corrupted during the download or some such. We just put them all in the same folder for ease of use. And here's a nice little file that it generates. It gives you the details of all the builds that have been churned out. And that can be used to populate the website. And that's the website I mentioned earlier. And you can see you've got this list of all the different builds. And if 11 with hotspot isn't your taste, you can click on the little down arrow there and it'll give you the different options you've got. So you've got JDK 10, we've got some JDK 9 builds. I don't know if we're still building anymore, but we do build JDK 8 and will be long into the future. So if you're not a modularity fan, we are still catering for your needs. Okay, so moving on, continuous integration. What is continuous integration? Who here has heard of continuous integration? Excellent, excellent. It's always a tricky thing to try and explain. Here we've got a blurb we grabbed that's good to explain it, especially as a reference. It's a coding philosophy. It allows you to implement small changes repeatedly to a product in order to try and get your changes in, rather than building up big clusters of changes or massive features before you push it in. You just put in individual bits, one chunk at a time, and then put in a chunk, and then you release, put in a chunk, generator, beta, whatever. So that way you can get a new code, in theory, you can get new code out to your clients faster, which is good because it shows you're more active. Such things usually go hand in hand with concepts like dark launches, where you create a feature but you don't enable it, which allows you to release a product that has that code in it without necessarily putting in a disclaimer saying don't use this. And that's good because it allows you to integrate your changes one little piece at a time until you're ready. Then you switch it on, and then all of a sudden your clients can use it. The technical goal of continuous integration is to establish a consistent and automated way to build, package, and test applications. So as you can imagine, because I've just talked your ear off about build farms that automatically build and test the application known as Java, that kind of goes hand in hand with what we're trying to achieve here. What we use continuous integration, continuous delivery for. We use build and test pipelines for the OpenJDK builds, which I've just shown you. We create official Docker images. I don't know how many of you have used Docker. I imagine it's a fair few at this point. It's spreading. But yeah, you can get Docker images that have our builds in them. So you can just spin up your little Docker container. It already has a build in hand. You don't need to go find the website. We have continuously deploy. We have APIs and the website, which you can use to get regular updates. So every day you get a fresh version of Java, assuming it passed all our overnight tests. And you can also get that via an API. So if you don't want to have to bother grabbing it manually every day, you can just set up a little thing that goes and fetches it, and we can accommodate that. We'll be talking about that in a bit, actually. You can we mirror the upstream mercurial forests. These days it's not so much a forest as it is a single mercurial repository. But yeah, we use continuous integration techniques in our scripts that we use to fetch the source code from OpenJDK. We've got a website staging bot, which I'm going to talk about in a bit. It allows us to try out changes to the website without messing with the live version. And we have a release counter, which is, it's a release counter. Here's an example. We've got the Adopt OpenJDK example, which is build, test, and deploy, which I've just talked you through, but we're going to cover it again. OpenJDK Mercurial repository is mirrored into GitHub. It's where we store the source prior to the build. That way, when we're running the nightly build, we're not so dependent on the speed of how quickly we can download stuff from OpenJDK. It's all contained. You've got the repository that's cloned into Jenkins. Then we try and build, which we showed you during the demo. If the build passes, then the test suites are kicked off. And if the test suites are kicked off, then the binary is shipped. The binary will either be released as a nightly build, which has so much testing applied to it, or it'll be released as a release build, which is much less frequent, happens about once every quarter. And it usually happens on par with Oracle's releases as best as we're able, and it has a much larger array of testing applied to it, much more stringent quality control, so you're getting a good Java if it's tagged as a release build.
Could you clarify what a trigger is at the start there? Because that's a sequence.
Yes.
It isn't an event, it's a...
The OpenJDK Mercurial repository is mirrored into GitHub. I believe that's a Jenkins job. I'm not too familiar with those Jenkins jobs, but they are initialized automatically. There's just a timer. So once a day, perhaps even several times a day, if we can get it to run nice and quickly, then it will just go and grab some new source and do that. Here's the example 2, the website deployment. So first, if you want to, say you spot a typo on the web page. So first you change the source code for the web page in a GitHub repository. You create a pull request for the necessary repository. The pull request automated bot running in Jenkins, and we'll talk about these in a bit, it spots that you want to commit a change. It takes your code and it stages it. What that means is it takes the changes that you've made, applies it to a copy of the website, and then loads it up in a way that you can get at it through the front end. So if you just open up your web browser and add the right combination of characters to the start of the Adopt OpenJDK URL, then it will bring up your nice staged copy with your typo corrected. And that way, GitHub reviewers can then review the stage changes, what it actually looks like in anger, before it goes live. And that's good, because then people can just review it and see, does this actually work? Rather than static analysis, which is always a bit hit and miss. Then if it works, pull request gets merged. We've got a GitHub webhook that triggers production jobs in Jenkins. Now what a webhook is it's something that allows you to run applications based on events that occur in GitHub. So when a pull request is merged, when a commit happens, when someone makes a comment, whatever, you can say, go to this URL and create a HTTP post and basically send a message to this URL and tell it that this thing has happened. And what we use that for is telling Jenkins to go off and say, well, this bit of code has just been changed in the website, so we want you to regenerate the main site and reload this fresh one. And that's what it does. And I know it works because I tried it the other day. Host prep. What we've gone through so far is some of the theory behind why we're creating the build system that we did and what we were trying to build with it and how that was kind of structured. Now we're going to be getting down into the nitty-gritty. It's the individual pieces of technology that we chose for each of the individual phases of the build. And why we did and what kind of lessons you can learn from that, and some of it's things you want to do and some of it's things you want to avoid at all costs. So first, host prep. Here we go. First of all, a bit of background. The Adopt Build Farm contains many machines donated and funded by these very generous people.
Is it actually a physical machine, or are you talking about?
Well, everything needs to be hosted somewhere. I understand some of them are physical machines hosted in places. I can't swear that all of them are actual machines and not just something hosted on a cloud server. I know not enough of it's hosted on the cloud as far as we'd like, and that's something I'm also going to cover later. Okay, the problem we were trying to solve in regards to all these different machines donated by all these lovely people is they have many different architectures in OS. It's a very diffuse group. How do we set up so many different machines? Somebody throws a half a dozen Macs at us and a couple of Linux PPCLE machines. How are we going to set up on those without breaking stride? How do we ensure that our toolchain dependencies remain consistent? So someone accidentally kicks off an update on a few of our machines. How do we make sure that we didn't just replace the version of the C compiler with something that won't build as we were expecting or won't build consistently? How do we scale quickly should the need arise? As I said, if we get a bunch of new machines all of a sudden, then we need the ability to quickly set up all these different machines at once. The solution is a concept called IT automation, and the tool we chose was Ansible. Why did we choose Ansible to set up all our different pieces of hardware? Well, because it's a de facto standard for setting up machines and open source infrastructure. And because it's a de facto standard, it means that lots of different projects use it, lots of different people use it, which means that we don't need to skill these people up when they join our project. They just show up and they already have the mental tools they need to understand our code and how it is that it goes about setting up all their different machines. It's agentless, which means you don't need to set up anything on the machines in question in advance. You just point Ansible at them and it will SSH in and run the commands it needs via SSH, which makes it nice and lightweight from the host's point of view. And it uses simple YAML syntax. Hands up who's had the pleasure of working with YAML in Anger. A few of you. You poor people. YAML, for those of you who don't know, is white space formatted. So that means the difference between one chunk of text and another is how indented it is. And anyone who's used Make will know how big a headache that can be. But okay, it's simple, it's straightforward. There aren't too many things for you to learn in order for you to learn YAML. What is Ansible? What it is infrastructure as code. You write your code in Ansible in what we call playbooks, which are then subdivided into roles. Roles are like class libraries that can be shared between different playbooks. And what you do is you write your playbooks and it says, I want you to install these things to this level and set up these folders and whatever, and it will go to each of your different hosts and make sure that happens. And the thing about Ansible is it does it smart. So it's not going to go installing a package if it's already there. It knows how to check that you've got the right version, and you don't need to worry about telling it to do that explicitly yourself. It's a nice and smart piece of kit. You just need to say, I want you to make sure I've got this package at this level on the machines that are in this group of machines. And it will just do it. How is Ansible run? You've got something called AWX, which is, it's Ansible Tower. And what it is a thing that runs Ansible. You've got automatic executions. You just tell it to go. You set up a schedule or an event or whatever, and it will just go and run and update your machines or make sure that they are still up to date. And like it says, it keeps hosts up to date. and it allows us to run regularly from changes in our continuous integration plan in order to keep all the machines on the same level. How is Ansible structured? We've got some playbooks in our GitHub repository, which is a source code management system I've mentioned earlier. An example use is inside the adopt OpenJDK Unix playbook directory. And if you crack that open, I'll show you an example on the next slide. You've got one YAML file, which is called main.yaml. And what it has in it is a list of roles. And so you execute main.yaml, and it will go through each of these roles in turn. You've got common, you've got debug, you've got autoconf, and it will go inside there and it will run the main YAML file in each of those, and it will install whatever needs to be installed as part of that. So inside the FreeMarker role, for instance, that might contain a set of instructions for making sure you've got FreeMarker installed on your various machines. FreeMarker is a package, by the way, it's a font rendering engine. You've got AntContrib, which is another package you need to make sure your machines have. You've got Ccache. We like to subdivide these things so that when something goes wrong or when you need to update a particular bit of the code, it's nice and modularized, it's easy to maintain and wrap your head around. It's nice and straightforward.
So is Ansible just a command execution, or is it looking and saying, oh, you've got FreeMarker, release 3, I need to do the necessary steps to take it to 4, because that's what it says.
What it does is essentially running commands. It's not like a scripting thing where you have to write them. Right. It's more you tell it to make sure, literally, I'm not simplifying things, it's you say go to these machines, and part of the instructions is make sure you've got this package at this version, go. And it will go and it will run the various commands it needs to see if it's already got it, what version it is, and it will remove the package if it has to and replace it with the one it wants and that kind of thing. And it will do all that kind of thing nice and smartly, so you don't have to worry about putting if and thens and...
You're just telling, your roles are just giving it a set of states, a set of end states that you want it to get to.
Basically, yes. And you can put all the stuff that's contained within the roles, you can put within the main.yaml if you like. We like to subdivide it into roles because your main.yaml file can get big quickly and it becomes difficult to poke through these things and figure out what's going wrong and what's happening. So we like to break it down. Here's an example of a main.yaml file. At the top, you've got your hosts that we're running these things on. This is what machine set we want to run this playbook against. We've got bits of code. We don't need to go into this in too great a detail. Here's your roles listed here. And this is a nice little list for you, and it will continue off the bottom of the screen. So it's just run each of these in turn. It's nice. It's pretty easy to read. And so, lessons learned one from implementing this stuff. The playbooks do get bigger quickly. If you don't start using roles at the start, you will regret it before your project is over. So we started using roles early and we haven't looked back. So if you do use Ansible to set up your infrastructure, it's worth using roles. Problem is Ansible changes your machines in a way you may not want. So if you're looking to run a build locally on your machine, you've thought, I'll just use the Ansible scripts on adopt to set up my machine in a way that allows me to build OpenJDK locally. You could do it that way. There's an expression, once you do blah, you'll never go back. That's much the case with Ansible, because once it's changed your machine, it'll change it in so many different ways that it can be difficult doing anything that you've done before, especially if it relies on packages that you've since stripped out by Ansible. One solution is to use a Vagrant to spin up a VM to run Ansible inside. Vagrant is a VM management system. And we have a Vagrant file that we provide. So you just install Vagrant, and you point it at our Vagrant file, and you say, go and spin up a VM for me that I can then run Ansible inside, and then run a build in, and That way you can just do it that way. Future plans, we plan to improve the Windows and Mac playbooks. So if anybody wants to get involved in Ansible or anyone wants to learn more about Ansible, then you can drop by the Adopt community. I'll put the link up again at the end of the presentation. And what we'd show you is what a good playbook looks like in terms of our Mac playbook, in terms of our Linux playbooks. And then we compare them to the Windows one, the Mac's one, and you'd quickly find out what makes a good one, what makes a bad one. So it's a good way to develop your skills in that area. And we're also looking to set up a Chaos Monkey, which is an interesting term I only learned a few days ago. It's something that randomly goes through your farm of machines and shuts down nodes, which seems like a terrible thing to me, but apparently it's not. It's something you can use to test your IT automation infrastructure to make sure that you can recover quickly from this kind of failure. So it randomly goes knocking things offline, and then your automation is supposed to then go and bring everything up and set it up again. 8, continuous integration server. You may recall I showed you some pictures of Jenkins earlier, and Jenkins is a continuous integration server. So what problem are we trying to solve? Our build process has lots of steps that we need to implement in turn. How do we automate the steps? How do we automate the flow from one piece to the other? And how do we enable continuous integration in this way, rather than just plugging together a bunch of scripts? The answer is we picked a continuous integration server, and surprise, surprise, we chose Jenkins. Again, we chose it because it's the de facto standard. Everyone has skills in it, and those that don't can quickly pick it up because it's got a nice, fairly intuitive graphical interface that's pretty easy to get to grips with. You've got modularity. It breaks the tasks down nicely into different jobs with different phases inside of each job, and you can view that, and it's nice and easy to understand. You've got low-level access to the machines, which not all continuous integration servers give you access to, so we have greater control during job execution. And it's also written in Java. Which is good other than the obvious, because so many people have Java skills these days that when we bring them on board, if we need a new plugin created or if we identify a defect, then we can go into the guts of it and figure out what needs to be done ourselves, which is good. Writing your own material is always good. How do we use Jenkins? As we showed you before, we've got pipelines of different jobs that we launch nightly and that we can launch manually as well. We have different jobs for different JDK versions. You may have seen we showed you the JDK 10 jobs and the JDK 11 jobs. We also have ones for JDK 9, JDK 8. We have dynamic host selection. So we might have a dozen or so Linux boxes, and if 2 of them are busy running tests and one's busy running somebody's manuals, then it will dynamically pick another machine from that list. So you don't need to worry so much about what machine you're going to run that on, and you don't have to wait until it's free. It will just pick the next one that meets your criteria. Jobs can run solo or in sequence. At one point they were pretty heavily tied to the sequence, but we since made sure they were more modular, so you can build and test, and you can do that separately if you want. So you don't need to run the whole suite of tests, or you don't need to build first in order to test. And the parameters control behavior. We showed you a list of when you start the pipeline, when you pick the different platforms that you want to run against, the different virtual machines, you can control how that works. What do our jobs look like? You may recall this picture we showed you earlier. We had a bit more screen space to show it to you before. So yeah, here's the breakdown. As you can see, we're spinning up the new jobs. Then we break it down into more jobs. We've got the build, we've got the tests, we've got the signing of the builds. And yeah, that's what they look like. I prefer the colorful graphs, but then I'm a simple person. We've got source-controlled build pipelines. Sorry, this is the first lesson we learned from running Jenkins. We've got the source-controlled build pipelines. So instead of just having, here's a job, and when you run it, it runs these instructions or this set of scripts internally. instead of just having that there where anyone can tweak it or change it, or where only the admins can tweak it or change it or whatever, anyone can damage it, anyone can modify it who's got access to it. Instead of that, we put the contents of these jobs in source control. We put them in GitHub repositories, in Groovy files, which just look like scripts to me, but that's me. And yeah, so it's good because it means that you can recover from issues. You can recover from giving the wrong person access privileges, and it's good to be able to control the content of your jobs in this way.
Is that a feature of Jenkins then, that their jobs are, you can save them out as a file instead of just a configuration?
I don't know. I don't have access to that part of Jenkins. Sorry, some of this I have to rely on third-party information. So yeah, another feature, something which I have seen, is continuous integration build failure tracking. So I don't know how many of you have used Slack. Used Slack before? Yes? Excellent. One of the things you can get is a little plugin that allows Slack notifications. Do not set these things to notify you on past runs, especially if you've got as many builds as we do. They will flood your channels. But yeah, if you get something to notify you on failure, especially if you've got a run green philosophy in your companies, it's definitely worthwhile, because you get notified immediately when something's gone wrong, and you're not reliant on an intern who's just sitting looking glazed at a bank of lights. On the Jenkins main page, you can get dynamic updates, which is good. It's very useful. It's a bit dry, so of course, yeah. You know what it's like, techies and spare time and an API. We plugged it into a nice little, what you can do to get information out of Jenkins. You can get regular updates on Slack, or you can go and get the information yourself. Here we see one of our enterprising developers has used a curl command to run a HTTP GET, and has fetches information on a regular basis from Jenkins, and gets information in the form of a JSON object, I believe. And what they use that information to do, they use that information to populate this nice little graph on one of their web pages with the status of all the different jobs that we've been running. And then they feed that information into a Raspberry Pi that's sitting on his desk, and it's lit up in bright colors. Like I said, we're simple people, but we do like that we've got a nice bank of lights. It's very twinkly. It's something to show people. And it's good because it means if something fails, we don't have to try digging out the one Slack channel that we're piping all the automated messages into. Future plan, we'd like to transition to on-demand hosting. So instead of relying on a static list of fixed bits of hardware, we'd like to have a link to the cloud. Basically, we'd like to say to the cloud, hey, we want half a dozen Linux machines and a couple of Mac OS machines. And then it says, sure, and it just spins them up and sends us the addresses. We'd love to have that set up. We currently don't. And if anyone here would like to get involved in setting that kind of thing up, by all means, give us a message on Slack and set you to work. Okay, build scripts. Build scripts, what they do is we run them on the individual host machines, and they build OpenJDK from the source. We run the pre-configure steps to configure the machine in question, fetching any dependencies we don't already have. We download the source code we need, we set up any folders we want, and then we just run configure and make with any options that we need to run in order to build the OpenJDK. It's basically a bunch of bash scripts. This is where it fits into the pipeline. You've got the overall pipeline. You've got it broken down again by, you've got the operating system, number of bits and the VM version. And then inside those, you have the jobs for build, test, packaging, And the bits in green are the build script parts, and that's where we're running the bash scripts on our various host machines. Here we go, here's the build script. It is a load of bash scripts. Why do we use bash? Because everyone knows what bash is. Not everybody likes what bash is, but everybody knows how to use it. It's a bit like make in that sense, except people like it more. It's widely available cross-platform. Again, everyone knows it. It's a universal skill set, and we figured it was one battle we don't have to fight. So we use bash. How do we use these things? You can either build natively on the machine directly, or you can tell the build scripts to spin up a nice little Docker container and run the build scripts inside of that. And it's a nice simple command in both cases. We like to keep it simple when we can. Here's the build script structure. I don't know if you can all read the writing. You've got the Make JDK Any platform at the top. You've got these two scripts, this is the main entry point, the nice simple commands I was showing you earlier. This launches these two configure scripts to get the configuration set up. So where are we getting the boot Java from? Where are we going to install to? Where are we going to get the dependencies from? What are the paths we need? Such and such. We have two different bash scripts depending on whether you're going to build it natively or inside Docker. And then we've got the build scripts, which connects to this prepare the workspace script, and it sets things up and builds inside it. So it's a nice simple breakdown of our scripts. This is a nice little blocky depiction of exactly what it does and how they're executed. Does anybody want to go through this again? Are we all right? Okay. This is the configuration step. We specify a load of variables. Some things we have to figure out ourselves. Some things are provided for us. Here are some defaults. We parse the user's options. We write out a nice configure file. And the configure file is useful because it means that we can then just pass it into the Docker container. We like to keep it simple. Here's the structure of build.sh. We invoke the native or the Docker build. We read in the generate configuration. You guys can read the slides if you're that interested. It's doing exactly what I said just now. It sets up the configure, it downloads dependencies, and it runs /configure and make in order to build Java, and then it packages it up at the end. Lessons learnt. We learnt in implementing all these bash scripts, we learnt not to rely on global or environment variables too much, because every single one of those is a wild card. So if someone's been on that machine before, if we've somehow failed to blanket between executions, then it can get messy quickly, especially if we're using debugging options in one run that we don't then erase at the beginning of the next run. It can get, yeah.
Is that where your Ansible scripts are buried?
I don't believe we run the Ansible scripts every single time between build executions. We do like to run them as regularly as we can, but the last time I think that we actually ran them across the entire network was several weeks ago. Yeah. So we try not to over-rely on environment variables. In fact, that's a general rule of thumb, which is good to stick with. We use shell check, which is a static script checker. So you run these things against your scripts and it will tell them if you're making common mistakes. What it does, you can go into more detail if you take a look at that URL. These scripts are available afterwards if you want to note down anything. You can use functions. So instead of creating a big honking script, you can break it down to individual pieces. We learned that we don't want to make the user modify their environment to fit our Snowflake build. God, John. Yeah, we want it to be nice and easy for the users to use. We want them to be able to download our build scripts and just run them on their desktop. And this enables you to do that. And although it's common and everybody knows how to use it, John hates it for many reasons. He's got a list, in fact. He made me memorize 2 of his favorites. There's a lack of associative arrays prior to Bash 4, which he won't forgive them for because we can't use Bash 4 because it's not available on Mac OS, and we like to keep things consistent, which means we can't use it anywhere. And there's no try-catch equivalent. So if you know you're going to run a bit of code and you think it might fall over horribly and you just want to run it and find out, you can't really do that with Bash because if it falls over bad enough, it won't get back up again. Future plans, move more builds into containers. As you've already seen, we have the ability to run builds in containers, but we don't always do that. We'd like to produce more installers. We'd like to reduce build times, increase the reliability of them because sometimes they fail and it gives people a lot of hard work that they don't need. And we'd like to reduce the special casings for various platforms, so we don't want people to have to worry too much about whether they're running it on Mac OS or Linux or whatever, you know. So we like to have as much common code as possible. It makes maintenance a lot easier. Okay, and this slide can be safely ignored because, as you can see, it is completely irrelevant. Archiving. This is a nice, simple section. When we create our builds, just to emphasize, we upload them using the API and we store them on GitHub for convenience. And here is our release process. When we have a build and we know it's passed all of our tests, we compress the binary into a nice little tarball. For those who don't know, tarball is just it's like a .zip. It's a package of different files lumped together. We compress it into a tarball. We generate a SHA-256 sum. For anyone who doesn't know what that is, it's a checksum. It's a string of digits that you can then compare to the build you've downloaded to verify that the build you've downloaded is the one that was created at build time. So you download the build, you can create a program if you're that concerned about corruption to compare it to the SHA sum, and it will just tell you whether or not you've got a good build that wasn't corrupted or partly downloaded or whatever. We've got a GitHub release tag that we create during the release process. Then we upload everything to GitHub for storage, and then you can use the GitHub API to get download links and grab yourself a nice copy of Java. And that's what our website does. Okay, quality control. Test goals and motivations. What we were doing with our tests, we wanted open and transparent testing of JDKs for the community, so we wanted anyone to be able to just show up and either run tests or view what tests were being executed against the JDK binaries that we provide. So we want people to just be able to wander in off the street and eyeball this stuff to know what we're doing. We want to find defects early so we can report quickly to the upstream projects. So that's report to OpenJDK, that's report to the OpenJ9 communities. There are various other communities that we report to as well, such as OMR and the like. We like to empower developers, so you can run all of these tests locally on your machine. Much like with the build scripts, we enable people to do that as well. So if you just want to download our tests and run them yourself, you can. It does take a while for the longer sets, so I'd restrict yourself to the sanity testing if I were you. You've got quick integration of new test material. We created an intentionally thin layer on top that allows you to access all these different testing infrastructures and frameworks that all the different subtypes of tests run on. We wanted people to be able to download, so we could download new groups of tests as and when we identify them and just plug them into this thing with minimal changes required as quickly as possible. And we've got a nice turnaround on that, actually. When we identify a new test set, we can bring it into the fold fairly quickly, just as soon as the lawyers are done with it.
How many
yes.
tests roughly have you got? Do you
run?
Thousands.
Full suite, thousands.
We have precise numbers on the following slides.
Ah, right. And follow on from that is how easy is it to identify duplicates or gaps in testing? When you've got that many.
Duplicates or gaps? I honestly don't know. We use test sets that are provided by various different groups, and one of the groups is the OpenJDK regression test suite created by the OpenJDK community itself. We also have the JCK tests, which is provided by Oracle, which is how you define something as Java. So does it meet the specification? And we do intend to run those against our hotspot builds. So we know that it meets the spec. We know that it passes all the tests that the community, well, not necessarily all the tests the community, because some of them are incredibly flaky, but enough of them. And we've got various different tests. We've got a test framework provided by IBM. So if they think it's good, and you've got profiling tests such as microprofile and such to guarantee the performance is good. Will it be 100% coverage? Unlikely, because there's a lot in Java. But we figure if we cast our net wide enough, we'll cover what we need to. Okay. So yeah, we want to make Adopt OpenJDK a center of excellence. Yeah. There we go. Here's your specific numbers. We've got consolidate and curate is what we wanted to do. So we've got, as I mentioned, the thin layer. It's called TestKit.gen running on top. And that allows you to execute all the different types of tests with the same interface at the top. So you just say what you want to run. You don't need to worry about how that framework is running it. You've got the functional tests, which come from the OpenJ9 community, which run on TestNG and command line tester. That's 20,000. We run nightly. You've got the OpenJDK community's regression test suite. That's run on JTReg. We've got almost 3,000 we run nightly, and 6.6 thousand that we run for releases because they take a long time to run. We've got system tests, STF. We run a lot of those, but it's in flux, so we just put X's there. And you've got external tests provided by third parties, so individual test sets for common applications. So we want to make sure that various products work, and we run those, and they're often in JUnit format, though there are in others. We're integrating microprofile and stuff like that. And there's about, we also run the TCKs as part of that, and that's about 50,000 tests in a container. And continuing on, we've got the JCK tests, which is 70,000 tests. The JCK test, by the way, 5 minutes. Okay, we're going to move on a little faster so we can cover the remaining bits. We've got lots of tests, is the short version. We have many tests. We've got the functional tests, which come from OpenJ9. We've got the OpenJDK regression tests, which often come from, which originally were intended to test hotspot, but they also test wider areas of OpenJDK in general. And they can be run against any VM, whether it's the hotspot VM that comes with OpenJDK or the OpenJ9 alternative. You've got the system STF tests, which are designed to simulate client scenarios. And that's actually very handy because STF, one of the things it does is it generates very complex scenarios, but in part of it is creating a small removable test case that you can then pass to developers when you're trying to repair a defect. So instead of giving them the entire framework, you can just give them that small extractable thing, which I always thought was very handy. You've got the external tests, which are application tests and microprofile. They're from outside groups. You've got compliance tests to making sure that we're meeting the spec for Java. And you've got performance tests, how fast we're running, to making sure that what we're producing isn't slower than what you'd get elsewhere. And the lesson is use scaffolding, which is cheap bits of cheap code to keep things going when you have to, especially if it's not customer facing, because as long as the tests run, it doesn't always have to run nicely, as long as you know you're getting the quality you need, but don't leave it there. as you can see further down when it says don't settle. It's good to keep things modular. It's good to get regular feedback from developers. A lot of this is just common sense stuff, but it's good to repeat these things. And what's next? We want to integrate a lot more tests, collaborate with a much broader community, and improve triageability via something called TRSS, which I have training to do on, and I haven't completed it. And we also want to develop some other services which will allow our test results to be much more useful to developers in the long run. How do I get this? How do you get a binary? You can get that from adoptopenjdk.net. You can get it from our API gateway. You can get a macOS brew package these days as well. And you can also get Docker images, including newfangled distroless, if you're familiar with that. It's Docker images that contain a Java that don't have a particular distribution of an OS associated with it. How do you get this via the web? You can get it via our website. How do you get this via the OpenJDK API programmatically? You can get it. This is complicated. There's a set of instructions on api.adoptopenjdk.net/readme. And what it basically means is run a custom curl command and it will get you, say, the latest Windows build using Hotspot. You can just tell it what you want and it'll go off and fetch it. And that's good if you want to make sure the Java on your machine or on your server on your cloud is the most up-to-date one of a particular version. Because that way you don't have to worry about updating it regularly. You just set that thing up to run every morning and that's it. Future work in this space, we want to support various types of packages, and we're also looking for contributions fairly heavily because we like to be able to distribute these things to as many people as possible. Summary, thank you for sticking with us. Not a single person fell asleep, which is good. Today we learned the basics. We learned what OpenJDK is, what Java is, what Adopt OpenJDK is, though I agree we could have done a better job explaining that. We had a demonstration of our build process. We used continuous integration. We showed you the philosophy that we're trying to meet. And we also talked you through a bunch of the tech we used and some helpful hints that I hope you guys can use in your day-to-day. And we're going to finish with these links. If anyone wants to join us, you can drop by adoptopenjdk.net. There's a link to our Slack channels at the bottom. Just drop by and wave your hands in the general channel. We're always happy to see new faces. So yeah, that's the whole thing. I'm finally going to stop talking. Thank you very much.